Hello everyone, welcome to Deeksha Karnataka YouTube channel, and today in the rapid revision series where we are trying to help you to achieve 65 plus marks in your board exam, we are going to discuss another important chapter, alternating current. Now alternating current is the chapter from where one definite numerical will come. Okay, so numerical question is going to come from this chapter along with some objective questions. So without any delay, let us start. First we will see the important concept of this chapter. So what are all the important concepts? DC and AC, difference between DC and AC, AC applied to resistors, phasors, AC applied to inductors, AC applied to capacitors, resonance and transformers. Now here you might say, sir, only one numerical is going to come, so only if I practice numericals then this chapter will be sufficient for us. But remember, there will be objective questions coming from this chapter, so if you don't study the concepts at least at certain depth, you will not be able to answer the MCQ question coming from this chapter. So please don't ignore the MCQ question, because at times some complicated MCQ questions do come from this chapter. For example, last year there was a phase diagram based questions which many students actually answered wrong. So don't do that mistake. Don't ignore the theory of this chapter, because based on this theory only you are going to get the objective question. Also theory is somewhat important to solve numerical questions, so don't ignore this chapter. So if you study this chapter, 8 marks, whatever 8 or 7 marks allotted to this chapter, you will score that marks without any difficulty. Let's start. First we will see what is DC and AC. So DC is called direct current that does not change direction with time. So that means if you have a current which is basically, say we have this is the current, this is say time. If the direction of current remains positive throughout, this is the ideal DC. No variation, constant current throughout the time, this is ideal DC. Some DC can be like this also, but it is only in the positive half of the graph. There is no portion in the negative half. So this is also DC. Okay, in fact in half wave rectifier this is also considered to be DC, full wave rectifier this is also considered to be DC. So these all are DC as long as current remains positive, current's value does not change with time. Value can change, but direction does not change with time. That is called DC or direct current. Now what is AC? AC is alternating current that changes its direction with time. So if you plot AC, so this is DC. Now if you plot AC, obviously the easiest AC graph that we use is sine function. There are other functions as well, but most common and most used, and for this chapter only one function that we need to know is the sine function. Sine function means it's like a sine wave. It can be sine, it can be cos. Both together are called sinusoidal waveform. Okay, sine, cos including, and generally they are called sine function or sinusoidal function. Both are same. Okay, so here we will start with sine, and sometimes we will get cos as well. So this is the general form of AC current. Okay, so here is IAC. So AC current varies. So if you see that for some duration of time the current is positive, so for some duration of time the current is negative as well. So if it is varying from positive and negative both, then only it is AC. If the variation is limited only in the positive zone, then it is called DC. Okay, now let's move on to AC applied to resistor. So we have seen DC current applied to a resistor, Ohm's law, right? The energy dissipated in a resistance, the series combination, parallel combination, those all cases are actually DC current. Even the cell combination of cells, okay, series parallel combination of cells, everything was based on DC current. Now what would happen if we take AC source and we apply it on a resistor? The diagram or the symbol for AC source is given by this. What is the symbol for DC source? Symbol for DC source was this. If you remember, this was the DC source. Okay, basically a battery or a cell. Okay, that is a DC source. For AC source, because it is varying with time, we generally do not have this kind of structure. It is denoted by this curvy little thing and the circle. Okay, Now let's see. So if you apply this voltage to a resistor, again your Ohm's law will still be valid, and you can calculate the current using the Ohm's law only. You don't need to learn anything new, and the current actually given by the Ohm's law. Current, maximum value of current is given by Vm by R, right? So sin omega t is only the term that is something new, it has been added. Otherwise, maximum value of current, later on we will see RMS value of current, they all obeys Ohm's law as it is. Okay, now what is the power dissipated? Power is the most concern for us, because any AC devices actually we use in our household, they consume power, and how much power it consumes is the utmost important towards us. So power dissipated is given by I square R, and it is given by Im square R sin square omega t. So there is a sin square omega t is extra term. Average power, now if you take the average of this term, so average of Im square R, Im square is a constant, R is a constant, so so this will be same as original value, only sin square omega t, sin function is not constant as it is changing with time. Okay, it can be 0, it can be 1 as well, and we are taking square as well. So the average of sin square omega t is not 1, okay, it is not 0 either, so it comes out to be half. So that derivation you may be doing in future, maybe you have done in mathematics class. I am not going to do how to find the average, but you should remember that average of sin square omega t, when omega and t, omega is constant, t is variable, in that case it will be half. But if theta is constant, that is sin omega t is constant, suppose sin square theta is a value, then its average will be same value. Okay, in that case you cannot calculate the average, it will be sin square theta only. Okay, because it is varying with time, then only the average term comes. So average of sin square omega t or sin square time varying component always will be half. Does not matter what is the value of omega, okay, it will always be half. So now this is something new, because in our DC circuit we learned that power was given by I square R, but here it is half Im square R. So to match the value, what we will be doing, we will bring a new quantity called IRMS, and IRMS is basically given by Im by root 2. In case of voltage, we will get voltage RMS, VRMS is given by Vm by root 2. And in our all day-to-day life, whenever we say AC voltage, suppose 220 volt AC, that 220 volt represents the RMS voltage. Okay, see if I say 2 ampere AC, 2 ampere AC means it is the RMS value of the current. So if nothing is mentioned, if it is mentioned that current or voltage with AC, that means it is RMS value. Maximum value of current will be generally higher than that of RMS value. So to calculate the maximum value, you have to multiply with root 2. Okay, so for example 220 volt that we use in our day-to-day life. Okay, 220 volt AC, 220 volt AC means this is the RMS voltage always. Okay, and the maximum value of voltage that we use around 311 volt. Okay, maximum value of voltage of the voltage that we use in our day-to-day life is 311 volt. Minimum value is 0, minimum value is not 0, minimum value is minus 311 volt, and in between there is a 0 as well. Okay, so that is very interesting. So we start with 311, we go down to minus 311, but when we say 220 volt, because that is the RMS voltage. Now let's move on to phasor diagram. So phasor is basically very important part of the AC chapter. In order to show phase relationship between voltage and current in an AC circuit, we use the notion of phasors. The analysis of an AC circuit is facilitated by the use of phasor diagram. A phasor is a vector which rotates about the origin with angular speed omega. Now what is the meaning of phasor? Phasor means, for example, we all have different phases in our life. Okay, one common phase is that we see is phases of the moon. Okay, so we say that, there is a complete new moon, then full moon. Okay, in between we have some other waxing gibbous and waning gibbous. So there are different phases of the moon we have studied in our childhood, right? Class 6th or class 7th, I think you have studied. So phases means as the sun moves around us, okay, we see, or as the moon moves around us, we see different light coming from our moon. Okay, and that is predictable. Similarly, when the current is being allowed to pass through a resistor or other components, we can predict how current and voltage will be related to each other. Okay, and that diagrammatic representation is called phasor. Okay, the diagram, phasor is a diagram. Phasor is a diagram. That's why it is called phasor diagrams. Okay, phasor itself has no meaning without the diagram. Okay, so for example, if you see that for resistor, we have seen voltage was given by Vm sin omega t and current was given by Im sin omega t. So if you see that both of these two terms have same sin omega t, whereas only the Vm and Im values are changing. Though only constant values are changing, but sin omega t is constant for both of them. So that means what? If you plot a graph, okay, both voltage and current both will move with the same angular velocity omega in a plane. We can represent it like that. So voltage and current both will have same omega t, so that means they will fall one over another. Okay, if this is the case, then we say phase difference is 0. Phase difference is represented by phi and phase difference is 0 in this particular case when voltage and current both having sin omega t. Okay, if they are giving you a equation, say V equals to Vm sin omega t and I equals to Im sin omega t minus phi, then what is the phase difference between these two equations? The phase difference between these two, so this is omega t, this is omega t minus phi, so phase difference is minus phi. If the same equation is given with the plus sign, then the phase difference will be plus. Okay, so based on the relative position, so if I is plus phi, that means I is leading. If I is minus phi, then I is lagging. Okay, based on who is plus, who is minus, we say leading or lagging. Okay, lagging with respect to what? With respect to the other one. So current is leading by a phase angle phi with respect to voltage. Current is lagging with respect to an angle phi with respect to voltage. Okay, so lagging or leading has to be based on something, right? So this is the basic concept of phasor. If you plot this kind of graphs, from there also you can find the phasor, but you should remember that if they are in the same phase, that peaks will match. Okay, that question came in your last year's board exam. Okay, so there was a difference in the gap. Now you have to identify who is leading, who is lagging. So in this case, both are having same peak at the same time. That means basically you can say that voltage and current are in same phase. Okay, now let's move on to the next part. I will explain it a little bit more. Okay, AC voltage applied to an inductor. Now we will take up inductor. Inductor we have learned in our magnetism, electromagnetic induction and electromagnetic inductance chapter, where if you apply a current pass through an inductor, what happens? It will induce a current in the opposite direction, which stops or which tries to prohibit the motion. And that's the main reason behind the inductance. Okay, now for DC current it happens for a few seconds. So as long as the current takes some time to establish throughout the inductor, current will flow. right? But when the current is stabilized, current is fixed, current is maximum value, the inductor does not apply any resistance, it just behaves like a simple conductor for DC circuits. For AC circuit, it behaves every time current's direction changes, the magnetic flux linked with the coil changes, and it tries to stop each and every moment. Okay, and that is why inductors are applied to AC circuit. Okay, so AC circuit, it always tries to stop the current change. Okay, it always acts like a as if it's like a AC resistance. It is like an AC resistance. The inductor is like an AC resistance. Okay, so normal DC current, inductor behaves like a conductor. Okay, but in case of AC, it behaves like a AC resistance. Okay, the current through an inductor is given by I equals to Vm by omega L sin cos omega t minus, and this can be represented by Im sin omega t minus pi by 2. So this is very, very important, that for an inductor, the derivation part we are not doing because derivation is not in the syllabus. So that's why we are skipping that. Only I equals to Im sin omega t minus pi by 2 is important, and that is the formula for current that is being allowed through an AC. Here XL equals to omega L is called inductive reactance. It is called inductive reactance, or the AC resistance of the inductor. Okay, this is the AC resistance of the inductor, so it is equivalent to AC resistance, and this unit is ohm, same as resistance. Okay, it will also have the same resistance ohm as your normal resistance. So this is the AC resistance. Inductive reactance is the fancy name. It is the AC resistance of inductor. Okay, thus the current lags the voltage. So as I mentioned that here, if you see, this is voltage was given by sin omega t, current is given by sin omega t minus pi by 2. So what is the phase relation? Phase relation is very simple, that current lags the voltage by an angle pi by 2. So if you plot the graph now, you will see that voltage is leading, current is lagging. Now this is the graph that you have to be studied a little bit carefully. So if you see that voltage is having a maximum first, voltage is having a maximum first, current is having a maximum after some time. Okay, so when voltage is at maximum, current is at some different value. Here it is 0 because the phase difference is pi by 2. In some cases you will find that the phase difference may not be exactly pi by 2, but you have to understand that whoever is appearing the maximum value, whoever is going to the maximum value first is leading. Okay, and whoever is having the maximum value next is lagging. So here current lags the voltage, voltage leads the current. Okay, voltage leads the current or current lags the voltage. So it is both way around. Next is power applied, average power consumed in an inductor is 0. So inductor does not consume any power in an AC circuit. Okay, even though it applies some resistance, it does not consume any power. Now before I continue, I just wanted to tell you that if you are preparing for your KCET exam and if you don't want to average out your power to be 0, you have to consider ABHYAS KCET test series, because here average power is not 0, but average power is your rank below 1000. Okay, if you are getting a rank below 1000, then that your average power is very, very high. But if you just do random stuffs, okay, practice from random question papers without any focus, without any proper simulations, then you will lose on rank and your average work will be 0, same as your inductor. Okay, so don't be an inductor. Okay, try to be a resistor where your average power is still there, even though you are not wasting some time of your life. Very important part of your career is this next 2-3 months. And in ABHYAS KCET you are getting 35 tests along with 4 free and 31 paid. New chapter wise KCET level PYQs that is absolutely free of cost, that will be given in the form of quiz. It is not just a question and their solution, it will be given to you as a form of quiz, and there will be a timer. You can answer those questions and you can check your understanding. Okay, how many of the PYQs you are able to solve exactly on your own. So that is why it is very, very important for you to purchase ABHYAS, and the price for this is only 1499. So let us continue with the discussion, and if you want to purchase ABHYAS, the link of the ABHYAS link is given in the description section of this video. Now AC voltage applied to capacitor. In case of capacitor, it is almost same as inductor. So if you apply a DC current to a capacitor, what will happen? The capacitor will be charged to the maximum voltage. Until then, current will flow, and as soon as the capacitor is fully charged, the capacitor will no longer connect any electricity. Okay, so capacitor basically acts as a filter for DC. It blocks DC, it only allows AC. Okay, it blocks DC, it only allows AC. Okay, so basically capacitor is exactly opposite to that of inductor. Inductor behaves like a pure conductor to DC, right? But capacitor behaves like a pure blocker for DC. Okay. The current through an capacitor is given by Vm by Xc into cos omega t, and Xc is given by 1 by omega c, is called capacitive reactance. So when you apply AC to a capacitor, it also gives an AC resistance. That AC resistance is 1 by omega c. Okay, and if you find the current will come out to be sin omega t plus pi by 2. Okay, that means current leads the voltage by an angle pi by 2. So if you plot the graph now, you will see that the current is having a maximum first. Okay, current is having a maximum first, then voltage is having a maximum later time. Okay, voltage is having a maximum later time. So whoever is leading, that quantity will have a maximum before the next quantity. That is how you can analyze and understand the graph. Now try to answer the question from your last year's PYQ. If you are not able to answer it, I will discuss it in another future MCQ section. Okay. Now let's continue. The average power dissipated in capacitor is again 0. Okay, it does not consume any power in AC circuit. Now LCR CD circuit. So we are discussing about simple R circuit, simple L circuit, simple C circuit. Now here we have combined everything together and we are calling it LCR circuit. LCR means inductor, capacitor and resistance all are connected in series. So in this case, the AC resistance of the circuit, the AC resistance, there is a resistance of there is an AC resistance of capacitor, AC resistance of inductor. So when you combine everything, you get the AC resistance, and that is called impedance. Impedance basically represents AC resistance. Impedance is AC resistance. And as it is AC resistance, you cannot simply apply the law of series combination or parallel combination. You have to use this formula. This is the most important formula for all of your PUC board exam, because based on this formula, they will ask you to calculate impedance of the circuit. So if it is only R and L, okay, then XC will be 0. If it is only R and C, then XL equals to 0. Some cases they will give you RC circuit, RL circuit. So don't afraid if something is missing, that quantity you can put it as 0. Now maximum current in this case is given by Vm by Z. Okay, and that can be written like this, but that is not super required. When XL equals to XC, then the current in the circuit becomes maximum. Okay, so Im becomes Vm by R only. Okay, so Z also becomes R. Okay, so Z becomes R, impedance becomes R, XL equals to XC, so XL minus XC becomes 0. This condition is called resonance. If the corresponding angular frequency is omega naught, then omega naught can be calculated by 1 by square root of LC, and the corresponding frequency is given by 1 by 2 pi square root of LC. Okay, so you have to remember that omega and frequency are related to each other. Okay, omega equals to 2 pi f. Omega is equal to 2 pi f, or frequency is equal to omega by 2 pi. This is a very easy relation to remember. Okay, most cases frequency will be given in your PUC exam, so you have to convert this formula to calculate XL and XC. Now let's move on. phase difference between when you are considering both L and C, the phase difference will not be 90 degrees, so it will have some other angle. So this is the common formula, tan inverse XL minus XC by R. Okay, and I equals to Im sin omega t plus phi. Okay, power in LC circuit. So if you try to calculate the power using this formula, again you will arrive at the formula that Vrms Irms into cos phi. The average power dissipated, average power is the something that we are interested in. Okay, here cos phi is called power factor. Okay, so if you calculate here XL minus XC by R is the phase difference, so what will be the cos phi? So power factor cos phi, this sometimes they might ask you what is power factor. Cos phi is R by Z. Cos phi is R by Z. So remember this formula. This is also can be asked in your PUC exam. Now few points. Circuit is resistive. If the circuit contains only pure resistor, it is called resistive. In that case, cos phi equals to 0. In this case, phi equals to 0 and cos phi equals to 1. Okay, there is maximum power dissipated. Purely inductive or capacitive circuit, if the circuit contains only inductor or capacitor, cos phi is 0, phi is pi by 2, plus or minus does not matter, cos phi will be 0, so power factor is 0, and in this case no power is consumed in the circuit. Now in LCR series circuit, in an LCR series circuit, the power dissipated is given by P is equal to Vrms Irms cos phi, where phi is equal to tan inverse XL minus XC by R. So phi may be non-zero in RL, RC or RCL circuit. Even in such cases, power dissipated only in the resistor. So in any condition, power is dissipated only in resistor. Very important for MCQ question. Power dissipated at resonance in LCR circuit. At resonance, XL minus XC equals to 0 and phi equals to 0. So cos phi is again 1, and again the circuit absorbs the most amount of power at resonance. Okay, clear? Now transformers. Transformer is the last concept of this chapter. For many purposes, it is necessary to change or transform an alternating voltage from one to another or greater or smaller value. This is done with a device called transformer using the principle of mutual inductance. So we have a primary, we have secondary. We change the current linked with the primary, and that induces a voltage in the secondary. We collect that voltage and we utilize it in our day-to-day life. Okay, transformer is the most important device for our power supply, and based on the number of turns in the primary and secondary, it can be a step up transformer, it can be a step down transformer. Step up means voltage you are increasing, step down means voltage you are decreasing. Okay, so now NS by NP is the ratio of number of turns divided by ratio of number of primary, and that is reversed to the current in the primary and secondary. Okay, now if you can calculate the power that is been there in the transformer, power is always input power equals to output power. So in an ideal transformer, the power is always constant. You have to remember that the power input is equals to power output in case of ideal transformer. This is the end of today's lecture. If you have any doubts, any questions, don't forget to mention that in the comment section below. And if you have not yet subscribed to our channel, don't forget to subscribe. And obviously, if you like this video, don't forget to give it a thumbs up. I'll be back with a new lecture very soon. Till then, bye.